Hi everyone, we are going to do a kinematics example problem. Now, if you are feeling confident, try this one in sections. So by this I mean we'll talk through a piece of the problem and then hit pause, give it a go on your own, and then hit play and then see if you and I agree and then try and do the next bit. So I think this is the only way you learn how to do physics problems is by doing physics problems. So here goes. A car accelerates uniformly from rest to a speed of 40 miles per hour in 12 seconds. Find the distance the car travels during this time. So we're going to start with part A and we'll do part B later. So first step, write down what you know. And a car accelerates uniformly from rest. Now what that means is I can use all my lovely equations for constant or average acceleration to a speed of 40 miles per hour. So from rest means my original velocity is 0. To a speed of 40 miles an hour means that is my final velocity, 40 miles per hour, in a time of 12 seconds. And we are looking for the distance or the displacement that the car travels. So what variable am I looking for? I'm looking for x. So hit pause, look at your list of equations, and pick out the right equation with this set of variables in mind. All right, are you back? Using this set of variables, what I would use is VF plus VO divided by 2. This VF plus VO divided by 2, this is the average velocity times time. And I'm looking for x. And I think I've got everything to put these in, except there is a problem. Did you spot the problem? The problem is this is miles per hour, and this is in seconds. So when in doubt, go to MKS, meters, kilograms, second, units. So I am going to get rid of miles, go to meters. There's 1609 meters in 1 mile. And I'm going to get rid of hours and go to seconds. There are 3,600 seconds in 1 hour. Now I'm going to pick up my calculator. 40 times 1609 divided by 3,600, and I got 17.9 meters per second. Now that I have this for my final velocity, I can put my numbers into my equation. So displacement is equal to my final velocity, which is 17.9 meters per second, minus my original, plus my original, which was 0, because the automobile started from rest, divided by 2, and this is times 12 seconds. So I'm just going to give myself a little more room on the page, and let's do the math. 17.9 divided by 2 equals times 12 equals, and I get a displacement of 107 meters. Now let's take a look at the units. Use the units in your problems as hints to determine if you are doing the math correctly. So here's what we've got. I've got meters per second, this meters per second, multiplied by seconds. So multiplied by seconds. Seconds on top, seconds on the bottom cancel. I end up with meters. I want a displacement in meters. Yahoo! I think I did that correctly. Okay, part B. If you're feeling confident, hit pause and try part B on your own. So here is part B. Find the constant acceleration of the car during this amount of time. So to all of the variables that I had before, I now can add acceleration. I am looking for acceleration, and I know this occurs in 107 meters. Now, if you look at your list of kinematics equations that contain acceleration, you have lots of choices. You could use VF equals VO plus AT, and that would work. You could use final velocity squared equals original velocity squared plus 2AX, and that will work. Or you could use X equals XO plus VOT plus 1/2 AT squared. And this part, because original velocity is 0 and there's no original displacement, all three of these would be acceptable equations. Which one did you pick? Well, I think I'm going to use the very first one. Why? Because it's really a sweetie pie. It's a nice little equation. So VF equals VO plus AT, but I'm going to solve for A. So I'm going to subtract VO from both sides. V final minus VO equals AT. Now I am going to get A alone, so I'm going to divide both sides by T. So my rate of acceleration will be equal to final minus original divided by time. Final velocity I found up ahead was 17.9 meters per second. So let's put that in, 17.9 meters per second minus original velocity of 0 divided by 12 seconds. So I am going to 17.9 divided by 12, and I get a rate of acceleration of 1.49 meters per second squared. Now we're going to take one more moment and look at where did these crazy units come from. I've got meters per second divided by seconds. When you are dealing with fractions, to divide, you invert and multiply. So meters per second times 1 over seconds. I end up with meters on the top. Seconds times seconds gives me seconds squared. Those are acceleration units. That's what I've got. I'm a very happy camper. All right, folks, we'll see you next time. Bye-bye.